Now let us study quartiles and quartile deviation. Now here the quartile deviation is the second measure of dispersion that we have to study. Now let's first understand what is quartile. Now suppose we consider the data to be arranged in ascending order from smallest to largest observation. More or less realistically, it is observed that the major chunk of the observations which matter for taking decisions, they lie in the middle 50% of the portion, isn't it? Because the observations on both the extreme ends are not typically useful to take decisions based on the data. So therefore what do is we imagine the data to be divided into 4 equal parts. That is the the whole range of observations we hypothetically divide into 4 parts, equal parts, and those values at the junctions we call as quartiles, denoted by Q1, Q2 and Q3, right? So there are always 3 quartiles denoted as Q1, Q2 and Q3. So what this means is between the smallest observation to the value Q1 there are 25% of the total number of observations. So that is, in other words, 1/4 of the observations lie between S and Q1. Similarly, 1/4 observations, that is 25%, lie between Q1 and Q2, and so on for the remaining 2. Alright, so that is the meaning of quartiles. Now let us go ahead and see the formulae to calculate the quartiles. So ith quartile Qi is given by I into n plus 1 upon 4 observation. So the observation that comes at this particular position is the ith quartile for raw and discrete data, and in case of continuous data we have a formula, that is L plus H upon F into bracket I n upon 4 minus Cf. Now you see this formula would look similar to the formula which we use to calculate the median, simply because median is nothing but the second quartile. So if you once again recollect, between the smallest and largest we have 3 quartiles, Q1, Q2 and Q3. So here Q2 is the one which comes exactly at the center, which is nothing but the median as per the definition. So therefore to calculate the median we must put the value of I to be equal to 2, because it is nothing but the second quartile, and hence the 2 will cancel out with this 4. Therefore in the formula for median we get n upon 2 as the first term, which comes from originally this general formula. Alright, so all other terms in the second formula are same as what we have for median. Okay, now let us solve the sums based on this formula. Find the quartiles Q1 and Q3 for the following data. So here we are given the raw data, and we must first arrange the given data in ascending order. So let us arrange the data in ascending order. The smallest observation is 3, then there comes 4, then 5 occurs 3 times, we have 6, 7, 8 and 9. Right. So the small n in the formulae represent the total number of observations. So here we see that there are total in all 9 observations, so n is 9. Now since this is raw data, let us write the formula for Qi. Qi is given as I into n plus 1 upon 4th observation. So therefore what will be Q1? Q1 will be, so here I is to be taken as 1, isn't it? So n is 9 plus 1 upon 4th observation. 9 plus 1 is 10, and 10 by 4 is 2.5. So it is 2.5th observation. Of course we never say 2.5th observation as such in reality. So what this formula actually means is, see, the way we calculate 2.5th observation is, it is second observation plus 0.5 into third observation minus second observation. So basically we hypothetically divide the difference between the second and third observation into two parts and take one part out of them, which is what we have 0.5. So now let's ask the question, like, what is second observation in the data arranged in ascending order? So that is 4. So you have 4 plus 0.5 into the third observation is 5 minus second observation is 4. So therefore you have 4 plus 0.5, and therefore finally we get the first quartile Q1 as 4.5. And similarly we can calculate the other quartile also, Q3. Now here it is 3 into 9 plus 1 by fourth observation. So this whole position of the observation. Now 9 plus 1 upon 4 we already calculated, that is 2.5. So 2.5 into 3 is nothing but 7.5. So therefore here we have to calculate 7.5th observation, which equals 7th observation plus 0.5 into 8th observation minus 7th observation, isn't it? So therefore see, what is the 7th observation? That is same as 7 coincidentally. 7 plus 0.5 into 8th observation is 8 minus 7, which is 1. So 7 plus 0.5 gives us Q3 is equal to 7.5. This is how we calculate quartiles. And based on the quartiles we define the next measure of dispersion, which is called as quartile deviation.